Hello, everyone. Welcome to another episode of Continuous Improvement, where we dive deep into the realms of technology, learning, and innovation. I'm your host, Victor Liang, and today we're embarking on an exciting journey through the world of transformer-based foundation models in natural language processing, or NLP. These models have revolutionized how we interact with and understand text. Let's explore the three primary types: encoder-only, decoder-only, and encoder-decoder models, their unique characteristics, and their applications. Segment 1, Encoder-only models, autoencoders. Let's start with encoder-only models, commonly referred to as autoencoders. These models are trained using a technique known as masked language modeling, or MLM. In MLM, random input tokens are masked, and the model is trained to predict these masked tokens. This approach helps the model learn the context of a token based on both its preceding and succeeding tokens, a technique often called a denoising objective. Characteristics. Encoder-only models leverage bidirectional representations, which means they understand the full context of a token within a sentence. The embeddings generated by these models are highly effective for tasks that require a deep understanding of text semantics. Applications. These models are particularly useful for text classification tasks, where understanding the context and semantics of the text is crucial. They also power advanced document search algorithms that go beyond simple keyword matching, providing more accurate and relevant search results. Example. A prime example of an encoder-only model is BERT, which stands for bidirectional encoder representations from transformers. BERT's ability to capture contextual information has made it a powerful tool for various NLP tasks, including sentiment analysis and named entity recognition. Segment 2, Decoder-only models, autoregressive models. Next, we have decoder-only models, also known as autoregressive models. These models are trained using unidirectional causal language modeling, or CLM. In this approach, the model predicts the next token in a sequence using only the preceding tokens, ensuring that each prediction is based solely on the information available up to that point. Characteristics. These models generate text by predicting one token at a time, using previously generated tokens as context. They are well suited for generative tasks, producing coherent and contextually relevant text outputs. Applications. Autoregressive models are the standard for tasks requiring text generation, such as chatbots and content creation. They excel in generating accurate and contextually appropriate answers to questions based on given prompts. Examples. Prominent examples of decoder-only models include GPT-3, Falcon, and Llama. These models have gained widespread recognition for their ability to generate human-like text and perform a variety of NLP tasks with high proficiency. Segment 3, Encoder-decoder models, sequence-to-sequence models. Lastly, we have encoder-decoder models, often referred to as sequence-to-sequence models. These models utilize both the encoder and decoder components of the transformer architecture. A common pre-training objective for these models is span corruption, where consecutive spans of tokens are masked and the model is trained to reconstruct the original sequence. Characteristics. Encoder-decoder models use an encoder to process the input sequence and a decoder to generate the output sequence, making them highly versatile. By leveraging both encoder and decoder, these models can effectively translate, summarize, and generate text. Applications. Originally designed for translation tasks, sequence-to-sequence models excel in converting text from one language to another while preserving meaning and context. They are also highly effective in summarizing long texts into concise and informative summaries. Examples. The T5, text-to-text transfer transformer, model and its fine-tuned version, FLAN T5, are well-known examples of encoder-decoder models. These models have been successfully applied to a wide range of generative language tasks, including translation, summarization, and question answering. Summary. In conclusion, transformer-based foundation models can be categorized into three distinct types, each with unique training objectives and applications. 1. Encoder-only models, auto-encoding, best suited for tasks like text classification and semantic similarity search, with BERT being a prime example. 2. Decoder-only models, auto-regressive, ideal for generative tasks such as text generation and question answering, with examples including GPT-3, Falcon, and Llama. 3. Encoder-decoder models, sequence-to-sequence, versatile models excelling in translation and summarization tasks, represented by models like T5 and FLAN T5. Understanding the strengths and applications of each variant helps in selecting the appropriate model for specific NLP tasks, leveraging the full potential of transformer-based architectures. That's it for today's episode of Continuous Improvement. I hope you found this deep dive into transformer-based models insightful and helpful. If you have any questions or topics you'd like me to cover in future episodes, feel free to reach out. Don't forget to subscribe and leave a review if you enjoyed this episode. Until next time, keep striving for continuous improvement.